Hey, you're back. It's Dr. D. We are working our way through descriptive statistics. The last thing we were talking about was how to make frequency charts for frequency tables for quantitative data. Oh, that's why. There we go. Frequency tables for quantitative data. The tricky part we saw was that there's not a natural separation in the categories, in the bins for quantitative data, right? For qualitative or categorical data, it's pretty obvious, right? You have different flavors, you have different colors, you have different categories that are kind of built in, right? They're cooked into it. But for quantitative data, it's not so obvious, and so we had to come up with some boundaries. And we talked about how to do that, and we were able to develop some methods, and so we were able to get some frequencies. We'll look at that a little bit more. Right now, what we're going to do is we're going to start looking at whoops. I'm trying to change my color. Here we go. Visualizations for quantitative data. There are a lot of these, so we'll probably get through a few of them in this video. Probably talk about a few more later. The first one, one of the simplest, is what's called a dot plot. So what we do here is, well, let's say we had a bunch of data, like, just make up some numbers, right? 25, 27, 32, 28, 28, 29, 31, 30, 31, 30. There, that's good. 10 numbers. We want to make a dot plot. The way that a dot plot works is you start with the smallest number, go to the largest number, right? So our whole range here goes from 25 to 32. And you just write all those numbers, 25, 26, 27, 28, 29, 30, 31, 32. And now, you go through the data, and whenever you see a number, you make a dot next to it. 25, dot. 27, dot. 32, dot. 28, dot. 28, dot. 29, dot. 31, 31, 30, 30. So that's a dot plot. With only 10 numbers, there's not, doesn't do much for you. You add more numbers, you get more dots. But it turns into like a little bit of a bar chart. We were looking at some data from the Weather Channel. And I'll show you that data. That's not it, that's my taco fillings. So this is the data that I collected from the weather. It's sorted already. Right? So we have it sorted. It goes from 85 is the hottest to 44 is the lowest. It's current temperature data from noon in mid-August or late August in 2012. That's where the data come from. But we know that the lowest number is 44, so we can start there. We'll call this temperature. And now we just say equals plus 1. We can copy and paste that all the way down until we get to 85. We want to get to. You can see that this has to be kind of big, right? It's not always the most convenient data visualization. Now, the way to make a dot plot in Excel, or one easy way to make it, is to get a count. So, and then I'll show you. Here we go. So, what we want is we want to know how many dots we need in each case. So we create a count column. We can do count if. Now, our range is going to be all the current temperatures, and I'm going to press F4 to put dollar signs in there. That makes these absolute references because that range isn't going to change. When I copy and paste this, I want it to be the same. The criteria, I just choose. You can see you can't see underneath it but you can see it's kind of twinkling there. It's just going to be E2. That means if it's equal to that, if it's equal to the thing that's in here, if it's equal to that, then I want it to count. Now when I copy and paste this, it's E3. So there was no 45s, no 46s, no 47s. There's 152. There's two 53s, two 54s, several 55s, and we can copy and paste this all the way down. If we do this, this gives us a count of all of these. That is essentially a frequency table that we just made, right? We can change this count to frequency if we want, but instead of having bins, right, we just have each bin is one, right? One degree wide. So that's not so useful. We can turn it into a dot plot relatively easy. The way that we do that is we use the REPT function. It just repeats text a bunch of times. The simplest way here would be to use like the letter O. tell it what text you want. You tell it how many times you want it to repeat. Now if I copy and paste that all the way down, you can see we have essentially a dot plot. I think that looks kind of ugly. I wouldn't want to print that anywhere, so I'm going to modify it slightly. The way that I'm going to do that is I'm going to insert a symbol. The symbols are over here. And I'm going to choose a Wingdings font. Okay. What I want is just a dot. Hey, there's a dot. Click close. Okay. So that's the text that I want to be there every time. If I copy this from the text, then I can go in here and change this to that by pasting it. Control V pastes. Okay. Now, when I paste this thing, we're going to get a bunch of different bars. I don't want it to be bars, but the problem is, the reason it's a bar is because right now that's still in Calibri font. If I change this to Wingdings, there we go, we have our dots. I still think that looks a little ugly. We can change the font color to blue. Maybe change the font size a little bit. And there we go, now we have a dot plot. You hide the ribbon and I can, here, I'll show you how to do this. View, let's freeze our top row. If we freeze our top row, then we'll see frequency. We don't really need the frequency anymore, right? But if we have our temperature, this is our dot plot. We have our temperature right here, and you can see that we have our dot plot. Scroll up and down, and this gives you a really, a pretty fast, quick visualization of what these look like. If you want to copy and paste it somewhere, it's really pretty easy to do. It looks good kind of on the edge of something. In this case, I guess since I'm pasting it into a paint, it kind of has all the, it's not totally elegant. If you paste it into Word, it looks really pretty. Okay, that's what a dot plot is. And that's how you make them in Excel. Just to show you the formulas again so you can see them. You can see what we used is we used a COUNTIF to count the data. We used some just basic addition to generate our numbers there. And then we used some repeating symbols from Wingdings to get our dots. I think that looks kind of neat. Oh, the other thing, I guess you can just go to View Grid Lines. There you go. Now you can see what it looks like without the grid lines. See, it's kind of nice. It's a good visualization. Put those back up there. Okay, so the dot plot is one way to look at it. Another one we can do is we can use a histogram. A histogram is kind of like a bar chart. I mean, it is basically a bar chart, but for quantitative data. So what we have, again, just like with a bar chart, is we have a horizontal axis as the category. In this case, it has the bins, right? With categorical data, it has the category. And then along the vertical axis, it has some measure of the, I stopped being good at this again. This is the frequency, right? Frequency, I'll just abbreviate it. So we have all our bins, and then we have our frequency. With a histogram, though, with categories, we wanted to have spaces in between our bars, right? To illustrate that they're separated. With a histogram, we don't want spaces because they're not separated, right? The cut points between them are arbitrary. And so by convention, we keep them right next to each other, and this gives us an idea of what the kind of the distribution, the shape of the numbers are. And so this whole thing gets colored in. Sometimes you have bars between, borders between these. But this is a histogram. It's kind of like a bar chart, but it's for quantitative data, and there are no gaps. Okay, so how do you do a histogram? Well, in Excel, again, it's pretty easy. Once you have your frequencies, which I showed you how to do in the last video, we can just use our frequencies to create a histogram. We want to select our bins and our frequencies. Right? Those will be our labels. Go to Insert, Column, 2D Column. And now you can get rid of the spaces between these two ways. One is Format Data Series, and you can just reduce the gap to 0. That's like that. Another way is you can just choose designs and chart layout 8, whichever one that is. I think it's this one. There you go. That automatically gets rid of them. So that gives you a histogram. I kind of like there to be borders, just so I can kind of see where they are. We'll give ourselves a border color. Make it black. Don't want it to be transparent. Make it a little thicker. There you go. Still a histogram. It's got some titles there it's asking us to put in. So what we'll do is we'll call this temperature range. We'll call this frequency. Oops. And then we want to change the title of the, clearly want to change the title of this thing to, let's call this a histogram for current U.S. temperatures on 8/22/2012. Cool. Look at that. Now that's too big, clearly. So make the font smaller. There you go. If you're looking out. Ta-da. Very pretty. Be happy to put that in a report somewhere, right? There you go. So that's how you make a histogram. Similar to the histogram is a stem and leaf display. Stem and leaf display is where the actual digits are used to kind of create a visualization. So in the example I had here with these numbers, right, 25, 30, that's not actually a good example because I don't have enough numbers. So let's add a few numbers to that. Let's say we get to, let's add 17, 18, 43, 44, 47, 43, 17, 19, 22. Okay. So to make a stem and leaf display, what we do is we use the last digits are going to be kind of our graphic, right? So this 5 is going to be used to measure this. So what we do is we look at the stem is the first digits, and it can be the first several digits until you get to the last one if you want. So we've got a 1, we've got a 2, we've got a 3, we've got a 4. These things are a little far apart, but I should still be able to make the connection here. And so now what we do is we say, okay, we got a 1. Let's look at for all the ones, all the things we have that start with 1. We got to put them in order really. So we have 2 7s, an 8, and a 9. Right? 17, 17, 18, 19. So we're going to write 7, 7, 8, 9. Right? Because 17, 17, 18, and 19. Now for 2s, we have kind of a lot of them, and I'm going to have to keep careful to keep these all sorted. But for 2s, I believe the lowest one is this 22. So we got a 22 there. And then we have 25 is the next one. So we got a 5 here. And we have 27. I think we only have one 27. So we got a 7 here. And we got two 28s and a 29. Right? And that should be all of it. So we're going to go 8, 8, 9. For 3s, we have a 30. We have two 30s, one here and one here. So we're going to go 0, 0, and then we got two 31s, 31, 31, 1, 1. We have one 32, and that's it for 30s. And then for the 40s, we have two 3s, a 4, and a 7. So we'll go 3, 3, 4, 7. And one of the nice things about a stem and leaf display is it still contains all the same data. And so it can be very useful for just kind of a quick look at the data. It kind of puts it in order, makes it a little bit easier to see. You can kind of see that, we have more 20s than 10s or 30s and more of those than 40s. And you can also see, that there are a couple 28s, a couple 31s, a couple 30s, a couple 17s, a couple 43s. So there's a bunch of modes. But if if this were naturally generated, you might have a more odd distribution. These are actually super hard to do in Excel. I can show you how I did it. I'll show you what it looks like when you do it. Where's mine? .apply histogram. Stem and leaf display. Okay, so what I did was I took my current temperatures here. Maybe sometime I'll make a video of this. I don't feel like that's time well spent right now. But so I had my current temperatures. I used the integer division, right, to get what the stem would be, right? Just divided them by 10, and then the remainder of that, which you can use the modulo function to get the remainder. That gives you the leaf. Now, in order to get Excel to sort them, it's a little bit tricky, right? So what I did was I used some if-then stuff. Basically, whenever it gets to a new this B2 equals B1. If you look at where that looks at, that's looking at the stem column. And it's basically saying, okay, well, if the current stem equals the previous stem, you want to concatenate them, otherwise you want to start fresh. And so in this first case, it's starting fresh, right? In the second case, the stem has already changed, so it starts fresh again, and then it starts concatenating them, 2, 3, 2, 3, 3, 2, 3, these are all sorted, so it just concatenates them until it gets to the 60s, and then it starts over again. And you can see that it does, this isn't formatted as text. If I format this as text, it'll be easier to see. Okay, so it's all concatenated now. So the problem then is, okay, now you have these giant kind of pyramids of numbers, but you only really want the longest one because that's going to be the thing that turns into your graph. And so what I did here was I looked at whether the length here was, since I know that the longest one is going to be right before a really short one, I looked to see if the length of the thing was longer than the next one, and if it's longer, then it's reported, otherwise it's just blank. So these are all blanks. Okay, so that gives me just the leaves kind of tacked on. Then I was able to copy and sort them over here, get stem, leaf, this looks it up, and then, I pulled them into these stem and leaf displays. So these are the stem and leaf displays. That can look a little bit ugly. The one reason I really wanted to show you this is just so you can kind of see like what we do to solve the problem, and it looks kind of ugly. And you can see that it is kind of ugly, right? It's just really long. It wouldn't fit really well on a page. So one thing we can do is we can cut them in half. You put everything up to 5, 1 through 5, in one row, just like here, see? And then you use the same stem and just show the ones that come after that. So this right here has now been split into these two. You can do that over and over again, and so that gives you a little bit better idea. Again, this is not something that's totally pretty. It's really easy to do by hand. It's one of the reasons once you have your data sorted, it's really easy to do by hand. And it retains all the original information. It doesn't have to, but it does in these cases. You can if you have like millions of numbers that are in the millions, sometimes you cut some of that out. But yeah, so it's one way to visualize your data. And here you can see for those temperatures, it does a pretty good job of showing us that the low 70s seems to be where the action is. And then it kind of fades away from there. Oh, one thing I want to talk about with histograms is skewness, right? So this is skew left. What that means is that there's kind of a big lump on the right, and then it kind of tails off to one side. That's one thing that histograms are very useful for, is kind of visualizing the data. And it turns out that stem and leaf displays, you can kind of see that right here too, right? You have kind of a big lump here. It looks kind of like a histogram made out of numbers. Okay, the last way that we're going to visualize data, quantitative data, is with what's called an ogive. In order to create an ogive, we need to come up with cumulative frequencies. And I haven't talked about cumulative frequencies yet because they don't come up all that often, but they're useful for creating an ogive. So let's go back to our relative frequencies and stuff. Or maybe just our... Okay, this is our relative frequencies. I'm going to copy and paste this so I can just delete the bar chart because we don't want that right now. We don't need these either, so we're just going to stick with our frequencies. Cumulative frequency just has, instead of how many fall within this bin, how many are less than the bin top, right? But basically that's what it is. So instead of cumulative, it accumulates, right? So instead of saying, okay, we want all the ones that are in this bin, we want all the ones that are in this bin or all previous bins. So here, for example, that's a dot plot. That's not going to help. Okay. So here we had 1 that was between 44 and 50, and here we had 8 between 51 and 55. The cumulative frequency would then be 8 plus 1. That would be 9 here. And so we can create a new column here that says cumulative frequency. The handy thing about this, actually, is that, well, for the first one, the formula is just the same as it was before. And this formula is just counting them to see if they're less than or equal to the bin top. Now, if you remember from the last video, I had to make an adjustment here. The way that I did this was I originally counted all the ones that were less than or equal to the bin top. That's this right here. And then I subtracted everything above it, so that when we got down here, we were counting all of these that were less than 75, but then we were subtracting everything here. For cumulative frequency in Excel, it's just this without that subtraction. So once we do that, it's really easy. Once you have the formula, it's really easy. By the end, it should always get to be the total frequency, right? However many there are, right? Because that's when you've crossed the line where you've gotten all of them. Okay, so that's how you calculate a cumulative frequency. An ogive is a graph that graphs these cumulative frequencies. What that means is just to draw kind of a picture of what you should expect an ogive to look like. Oh, and I might as well spell it for you. Ogive, which apparently is also like the shape of like a torpedo, like kind of this shape. There's a missile. This kind of a curvy arch. And then if you've ever been in like a cathedral that has like arches that kind of shaped like that, that's also called ogive. Anyway, in ogive, what it has is temperature, or whatever, it has your category, your variable, and then it has frequency, but instead of being a regular frequency, it's a cumulative frequency, which means that it always ends up here. Right? It always starts down here and ends up here, and sometimes it looks like this, and sometimes it looks like this, but it always kind of finds a path from, if it's just straight, that could be one ogive, but that's going to be very odd that you wouldn't find in nature. But yeah, that's what cumulative frequencies look like. They'll never go back down, right? So that's not allowed. Can't happen. It can only go up. It's a non-decreasing. It can go horizontal and then jump at the end or something like that. But it's always going up, right? Because it's just accumulating. It's snowballing. Right? That's the idea. So how do we make an ogive? Well, what we want to do is we just want to make a line plot. An ogive is just a line plot where we plot these cumulative frequencies. The thing is, so this is going to be what's on the y-axis, right? On the x-axis, we have to pick something. And because what we want is everything that's less than or equal to this value. Unfortunately, when we create bins like this, there's in between stuff, right? So this one, it's not clear whether it's less than or equal to 50 or 51, right? You don't want things to fall in the middle. And so the way that we usually do this with discrete data is that we just add 0.5 to the bin top. And this gives us our ogive x, right? If we do that for all of these, that'll give us midpoints in between the bins. That's basically what we're doing, right? We're trying to create midpoints between the bins. Okay, so how do we create a line graph? Well, we select all of our x-axes, our x-coordinates, as well as our y-coordinates. Go to Insert, Scatter, and then we want a line. We want to scatter with straight lines. Okay, so there's our cumulative frequency. Again, this is ugly. I don't like it. I want to fix it. So we know that our minimum, I want to format the axis. We know that our minimum is actually 44. So I'll make this 43 just to be safe. We know that our maximum is 85, so I'll make it 86. We want our major unit. I want to be able to see some stuff going on here. And we'll make our minor unit 1s with some minor tick marks. So those are our temperatures. I'm going to add some. Is that good enough? We probably don't need to mess with this too much, but I know that the maximum here is 96, so I'll make it 97. And then I'll change the title. It's going to be ogive for current temperatures. Oops. Copying, move that down here. Drag this up a little bit. We don't need the grid lines necessarily. You can keep them if you want. And then it's also kind of traditional to have markers on here. So I'm going to add some markers. There you go. Last but not least, I want there to be a title at the bottom. It just says temperature. Oops. There we go. That's an ogive. You can see that it starts out low and gets higher until, and you can kind of see that it starts, where it's going up slowly, there aren't so many of them, then it starts going up really fast. That's because that's where it's picking up steam. That's where it's getting most of the results. So you copy and paste this wherever we want into your report. And now you have the last visualization for quantitative data. We got some histograms, we did stem and leaf plots, right? We did dot plots, and now we did ogive. And those are the ways, some of the ways to look at quantitative data for one variable, right? Next time, what we'll talk about is two variables, how to kind of look at data that's related to each other. And that's really helpful and useful and common. So yeah, so we'll take a look at that. Hope that was useful. Hope that was interesting. If you have any questions, as always, just drop me a message or leave a comment. I'm happy to help. And talk to you guys again soon. Thanks. Bye.